All right, so let's talk about these. Now, when we search for an angle, the first thing we might do is write down some of these important angles that are on the axes. So in degrees, we've got, of course, 90, 180, 270, and then if we keep going around, 360, and you could keep going around and around and around and around if you really wanted to. Okay, so 240 degrees, where would that be? So I'm going to write on here. All right. So it's obviously between 180 and 270, right? And which one is it closer to? Yeah, it's closer to 270. And more specifically, how many degrees away from 270 is it? 30. So that's one of those important angles we talked about the other day. So 240 would be right there. When you're answering these questions, you're basically just going to draw a line. So which direction would you be facing when you stop? So 240 would be right there. It's 30 degrees away from 270. It's 60 degrees away from 180. These multiples of 30-degree angles are going to be important. 315. Again, we're using degrees, and you want to be able to do this without having to look back at your notes. So make it easy for yourself. Mark the angles on the axis. So 90, 180, 270, 360, and you just keep going until you trap it. So it's between 270 and 360, right? And in fact, in this case, it's exactly halfway in between, right? It's 45 away from 270. It's 45 away from 360, so it is right in the middle. So we'll draw it right in the middle. And then for 60 degrees, we'll start at 0, and then we get to 90. And hey, we've already trapped it. It's between 0 and 90, so it's in the first quadrant. And which side is it closer to? That's right. It's closer to 90. Okay. That's okay. All right. So any questions there? Okay. The ones that are a little bit more tricky are the radians. At least that's my opinion. You might share it. You might not. So let's say I want to find pi over 6. So what we did yesterday is we would set up our important angles all written with the same denominator. So instead of pi, we would write what over here? Yeah, we would write that as 6 pi over 6. And instead of half of a pi, we would write that as 3 pi over 6, like so. And then 1.5 pi, 9 pi over 6. So we're going to think about all of these angles in terms of sixths of pi. So where is 1/6 of pi? Well, it's between no sixths and 3/6, right? Closer to none. So there. That's pi over 6. By the way, how many degrees would this angle be? Do you remember? Yeah. It's a sixth of pi. And what is pi in degrees? It's 180. Yeah. So it's a sixth of that, which would be 30. 3 pi over 4. Let's try and find that one. So again, we're going to write our angles in fourths. So we've got 4 pi over 4 instead of just regular pi. And then half that would be 2 pi over 4. And it's going to be in between those two angles right there. In fact, it's going to be exactly halfway in between them. Any idea what that angle would be written in degrees? Yeah, so in degrees it's between what? It's halfway between what two angles? Yeah, it's halfway between 90 and 180. What's halfway between 90 and 180? 135. Okay, this one is 7 pi over 6. So again, we're going to write our angles in sixths. So there are 6 sixths. And it's bigger than that, right? So it's not going to be on this side. It's going to be past 6 pi over 6. This would be 1.5 pi, so 9 over 6. And it's going to be in between those. And it's going to be closer to 6 pi over 6. So there's 7 pi over 6 right there. Okay. Any idea what this would be in degrees? Let's think about this. So it's pretty close to pi, which is 180, right? In degrees. That's 180 degrees. How far past pi is it? Yeah, it's 30 degrees. It's that same pi over 6 angle. That's how far past this 180 degree mark is. It's 30 degrees past. So it would be 2, 2. Okay. So when we're dealing with these important angles, I'm going to call them, these multiples of 30, like 30 and 210, or multiples of 45 degree angles, like 135 is 45 degrees away from 90 and from 180. This one's 30 degrees away from 180. This one's 30 degrees away from 0. So these 30 and 45 degree angles, these are the ones we're going to use the most often. And if we can draw these pictures and figure out where these angles are, we can easily convert between radians and degrees for all of these angles without having to do actual calculations, just by a little bit of counting. By being able to figure out where an angle is, so 7 pi over 6, okay, that's a little bit past pi. Well, then it's going to be a little bit past 180, so it's 2, like that. Okay, so these are going to be important everyday skills in geometry, in pre-calc. Okay, so let's talk about these important angles. Okay. We talked yesterday about finding angles that are an entire multiple, a whole number of pi, like 3 pi or 4 pi or 5 pi. So where are those angles always going to be? So which direction would, let's say, 2 pi be pointing? To the right. Same place as 0. So 0, 2 pi, any even multiple of pi, right? Is going to be pointing to the right because it's a multiple of 2 pi, which is one circle. What about an odd number times pi? To the left. Like pi, or 3 pi, or 5 pi. Okay, so these angles are really easy to find. These are going to be some of our important angles. And usually when we're trying to find some angle, especially if it's in radians, we're going to base it off of the placement of pi and work our way around from there. And of course, these angles would be multiples of 180 degrees if we're working in degrees. The next most important angles are the ones that are at the top and the bottom along the y-axis. So these I'm going to call multiples of a half pi, pi over 2. So we've got a whole number times pi. In this case, we'll have something like pi over 2. So for these angles, we end up using the top of the y-axis, the bottom of the y-axis. So if we're looking at this first circle as we go around the first sign, there's pi over 2. What's this angle at the bottom? That's 1 1/2 pi, right? So there's 1 pi, and then there's another half. And if we're thinking in halves, we could write pi as 2 pi over 2, right? And this angle over here could be 0. It could also be 4 pi over 2. So in this case, instead of counting by half circles, like we do with a whole pi, or 180 degrees, we're counting by quarter circles. And how many degrees is each of those quarter circles? Yeah. So if we're trying to find some angle that is a multiple of pi over 2, like if it's 7 pi over 2, then the only angles we need to consider are these half pi angles. They're 90-degree angles. So we go 1, 2, 3, 4 pi over 2, 5, 6, 7 pi over 2. It would be right there. You just have to count these endpoints. The next set of important angles would be multiples of pi over 4. The other day we drew a big circle using a CD as a circle drawing tool, and we drew in all of these angles. So if we're working in fourths, I'm going to go ahead and write these other important angles we've talked about in fourths. So there's pi, but I'll write it as 4/4. Here's a half pi. I'll write it as 2/4. Here's 1 1/2 pi. I'll write that as 6/4 of pi. Then this could be 0, or it could be one complete circle. It could be 8 pi over 4. So where would 1 pi over 4 be? Yeah, right there. So my fourths of pi are halfway in between my halves of pi. So these are the on the diagonals right here. So there is 0, then I've got pi over 4. So let's say I wanted to find 7 pi over 4. What can I do? Well, if I know I'm counting by fourths of pi and I know how big those are, I just count. I say, okay, 1, 2, 3, 4, 5, 6, 7. It's right there. So that's what we want to be able to do. Find these things just by counting. 1, 2, 3, 4, 5, 6, 7 out of 4. And this works really well if I have an even bigger angle, like 15 pi over 4. What would I do? Well, I could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Done. It's right there. Okay, so maybe you see how this could be helpful. It makes it really easy to find angles if you just know what to count by. And we can all count, right? At least to like 20 or so. Maybe 30 on a good day. Okay. We also have, pi over 4, how many degrees is that? Yeah. Maybe, but maybe 45. Yeah, so it's half of this 90-degree angle, right? So it's half of 90, 45. And the last set of important angles we have are the multiples of pi over 6. And pi over 6 we already talked about is how many degrees? Yeah. Hint, it's a sixth of 180, which is 30. Okay. So this time, I'm going to write my important angles in sixths, just to set this up. There's 6 sixths of pi, or in other words, pi. Here's nothing. Or if I make one complete circle, I double this number. That would be 12 sixths of pi. That's 2 pi. Or if I cut that in half, that's 3 sixths of pi. Or if I do 1 1/2, that's 9 sixths of pi. So the important thing here is knowing basically how to count. So this is the one that we drew the other day, where it had we had angles in the same position as the hours of a clock. And if you know you're supposed to get to 3 by the time you get to this 90-degree angle, that can help you also, because 3 is half, 6 is half. Okay, so then when I start at 0, I want to count 1/6 right there, 2/6, 3/6, 6. Why is that so hard to say? Like so. Okay, so pi over 6 is going to fall at the first hour mark right there. And then 2 pi over 6, 3 pi over 6. So let's say I wanted to find 15 pi over 6. What am I going to do? I'm going to know, okay, I'm counting by sixths. Those are my 30-degree angles. So I should have 3 of them. 1, 2, 3, and then 3 more. 4, 5, 6 out of 6, 7 out of 6, 8 out of 6, 9 out of 6. And I can just count 10, 11, 12, until I get to 15. 13, 14, 15. Whereas 15 pi over 6, it's right there. So I count by these sixth marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And 15 pi over 6 would be right there. So what we're trying to do here is make this easy for ourselves. Make it easy, make it intuitive, and save you from having to do a bunch of calculations anytime you want to figure out where an angle is. We want to be able to do this intuitively by counting, and we want to be able to do this without having to look at our notes. So when I give you a quiz over this, which I am tomorrow, it's going to be without your notes. I'm going to want you to be able to find these without just having them all written down already. Okay. Pretty much. Okay. So these are the important angles that we're going to be using every single day for all sorts of stuff. So if you don't remember pi over 6 in terms of degrees, the more familiar unit that you're used to, just think about pi as 180. So it's a sixth of 180. That's 30. Pi over 4. That's a fourth of 180. Because pi and 180 are the same angle. It's half a second. Okay. So let's practice this a little bit with these important angles. We already have practiced it a little bit. So here are the instructions I gave on the homework assignment over this stuff that I haven't posted yet, and also on the that'll be on the quiz. So for these important angles, we want to not only draw them, so in other words, locate them, but we also want to be able to convert easily between degrees and radians. So if it's in radians, we want to convert it to degrees. If it's in degrees, we want to convert it to radians. Important life skill that will be made easy by drawing these circles. So first, I'm just going to write down some angles. I'll go through a couple of them with you, and then I'll let you try some. Let's see, let's do degrees on this side. So each of these angles is going to be one of those important ones. Either a multiple of 30 or 45 or 90, which is also a multiple of 30 and 45. So a multiple of 30 or 45, basically. I might throw in a negative one just for fun. Or that means go backwards. Here's some in degrees. Here's some in radians. I will. Let's go through a couple of examples first, just so you can see this process from scratch, and then I'll let you try some of these without having to listen to me talk about it. Okay, so let's find 300. So the first thing I'm going to do is draw some little crossbars in there, just to orient myself. I know I've got 0 here. So 300, what is that a multiple of? Would this be a multiple of 30, a multiple of 45, maybe a multiple of 90? What should I be counting by? That's the question. And really, for degrees, because you're already, I guess, pretty good at working with these types of numbers, if you're not sure, it might help to go ahead and write down these marks over here. Okay. So I've got my axis marks on there. So I know it's between 270 and 360, right? So how far away from 270 is it? Okay. So it's 30 degrees past 270. So it's going to be right there. Or 60 degrees away from 360. So it's one of those multiples of 30. Right? Because it's a multiple of 30 away from all these other important ones. So look at the differences there. 30-degree difference. So it's a 30-degree angle. We want to write it in radians also, because it's in degrees right now. So how am I going to write that in radians? Well, what would this angle be in radians? This 270. Or actually, let me back up. So we said this was a multiple of 30 type angle, right? This falls into that class of angles. So then what fraction should I be using if I'm going to try and write this in radians? Yeah, I should be using sixths. So then I just have to count by sixths. How many sixths is that? 1, 2, yeah, it's 10. 4, 5, 6, 7, 8, 9, 10. 10 sixths. So it's 10 pi over 6. So if I know what to count by, all I have to do is count. Or if you remember that this is 9 pi over 6, then you just have to add 1 from there. So there are various ways to make this easier for yourself. And of course I can reduce that to what value? Yes, 5 pi over 3. Because I counted. 1, 2, 3. So I'm counting by sixths, which are the 30-degree angles. So 300 would be 30 degrees away from 270, right? So that tells me I need to be counting by 30s. If it was 45 degrees away, I'd count by the 45s. Yep. Mm-hmm. So it's going to, each of these important angles is going to fall into one of these categories. So you just have to figure out which category it's going to be. So because this is 30 degrees away from something, it's a multiple of 30. If it was 45 degrees away from 270, we'd count by 45s, or by fourths of pi. If it was on one of the axes, we could count by halves of pi, or 90s. Sorry? Yes. That sounds very important. Alright. 7 pi over 4. Let's try and find this one. So this time we're starting out in radians. So basically the fraction is going to tell us what we should be counting by. which would be counting by fourths of pi. And fourths of pi, those are those 45-degree angles. So all I need to do to find the angle is just count to 7, if I'm counting the right angles. So there's none, then there's 1, 2, 3, 4, 5, 6, and there's 7 pi over. Okay, so I know I'm counting by fourths. If I know how big a fourth of pi is, then all I have to do is count to 7. And we can all count to 7. It's counting 9, I think it's hard. To 7, 8. Okay. So, do we understand how I found this angle right here? Ask him now. Yes. So, yes. So, it's easy. So, I'm counting by fourths of pi, right? Because that's how my fraction's written. And how big is a fourth of pi in radians? Yeah, it's half of a 90-degree angle, right? So 45. Yeah. So you can say, well, okay. So now let's think about this in degrees. So here's 270. Here's 360. It's going to be 45 degrees away from each other. So it's 45 degrees past 270. So 315. Yeah. Okay. I guess I should draw it. I didn't know. Alright, that's the idea. So, I'm going to let you try some of these other ones instead of watching me do it, unless you want to see one more. Yeah? Uh-huh. Yeah, the pi angle would be negative also, the radian. Yeah. Just go down. I would like you to. Right. So give these a shot, and try to do it if you can without looking back at your notes, because that's the way I'm going to want you to be able to do it on the quiz. And then when we use this in class doing other things, every single day. by the way, since no one's asked me about it yet, I assume a lot of you have figured this out. But if I want to find pi over 3, and we haven't talked about counting by thirds at all, what could we do? Yeah, good. So pretend it's 2 over 6. All right. I'm going to run through these real quickly. I want you to be able to do these pretty quickly as well, although you're just now learning, so it's okay. But so on this one, so negative 120, I'm going to go this way. It's going to be 30 degrees past 90. So it's a multiple of 30, which means we're counting by sixths of pi. That's the same thing as 30 degrees, so there's 1, 2, 3, 4. So it would be negative 4 pi over 6, or negative 2 pi over 3, because it reduces. This one, we'll count by sixths of pi, and here we're going the positive direction. Sixths are the hours on a clock. 6, 5, 7, 8, 9, 10, 11. So I count to 11 pi over 6, and I get right here. And that's almost a complete circle. So if I'm thinking about this in degrees, it's between 270 and 360. How far away from 360 is it? Yeah, that would be the 30-degree angle. It's less than halfway, so it's going to be 330. So it's 30 degrees short of a circle. That's a mean thing you can say about somebody. You can say they're 30 degrees short of a full circle. But you shouldn't. 225. Now, if it ends in a 5, and I told you it's one of the important angles, it's probably not a multiple of 30 or 90 or 180. It's probably a multiple of 45. So here's, I know it's between 180 and 270, and it's going to be halfway in between, exactly halfway in between, which means it's going to be a multiple of 45, which is the fourths. So count by fourths. 1, 2, 3, 4, 5, 5 fourths. Negative pi over 3. I said, to pretend it said negative 2 sixths. So that's what you'll count by sixths. So there's negative. So we're going to start from 0 and count this way. 1, 2. Negative 2 sixths. Right there. And that is, because we're counting by sixths, we're counting by 30 degrees, so there's 30, negative 30, and there's negative 60. That's negative 60 degrees. It's 30 away from negative 90. On 270, we've seen this angle enough already that you might just know where it is. It's straight down. It's right there. 270 degrees. Because it's on an axis, you can count by halves of pi, or you can count by fourths of pi. You get there eventually. You can count by sixths of pi. It doesn't really matter. But it's 1 half, 2 halves, 3 halves of pi. (13 fourths). I know I should be counting by fourths because that's the denominator, and it's one of our special numbers. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's there. And what angle is that? Well, it's in the same place as 225 was, that we did earlier, but we had to make an entire circle first. So how many degrees should we add to that 225? Or we'll think about it this way. Yeah, so we go around 360, and then we count around another 225 degrees. So it's 225 plus an extra circle plus 360. So 585. It is coterminal with 225, word that we talked about. What about 450? So this one is past 360. So I'm going to go ahead and count around to 360 and go from there. How far past 360? Yeah, 90 degrees past it. So it's going to be straight up and down, the same place as 90 degrees. It is coterminal with 90 degrees. So in radians, yeah, we can count by half radians because it's on the axis, just like the one above. So there's 1, 2, 3, 4, make a full circle, and then 5 half radians, 5 halves of pi. So 5 pi over 2 would be right there. So again, count by halves. 1, 2, 3, 4, 5. What about 11 pi? Well, let's say whole pi, so it's going to be either to the right or to the left. Yeah, and odd ones are to the left. A little shortcut. Another little shortcut. Instead of counting by 180 degrees a bunch of times, is there an easier way I could turn this into a degree measurement? Make it a little simpler for myself. I probably could. So it's 11 times pi, right? What if I want to think about pi in terms of degrees? How do I write pi in degrees? What's an equivalent angle measurement? Yeah, pi is half a circle. That's 180. So it's 11 times 180. So instead of counting around, I can save myself a little bit of time there. That would work on these other ones too. It's just extra math. But here it would actually be easier probably if we're trying to add 180. That's the same thing as multiplying. Okay, so how do you multiply stuff by 11? First, you write down the first number. That's 1. Then you add the first two numbers together. Right? 1 plus 8 is 9. Then you add the next two numbers together. 8 plus 0 is 8. And then you write down the last number, 0. Actually, you would want to start with the last number in case something carried. So first write down the 0. Then add the last two digits, and you get 8. Then add the next to last two digits, and you get 9. And then when you run out of digits, you just take the last one by itself. Yes, that's specifically for 11. And if you write it out longhand, it makes it. Okay. So I'm trying to print out a copy of the homework page for you, but the printer might not be working. So if not, it's on your classroom. Printer is still kind of working. So I'll set this is more stuff like that. You'll want to practice, or else it will just find a way to slip out of your brain. That's sort of how your brain works. You need to strengthen the connections to the material that you actually want to remember. So I'll post that on Google Classroom. Some extra practice problems, draw some angles, and when you're doing them. So when you're doing these problems, you want to do them from memory if you can, because that's what you need to be able to do this stuff just as background processes when we're doing other things. So try to do them from memory and try to do it fast. Speed here is an important goal because this is just going to be stuff that has to happen in your brain as we're going